In this tutorial, we are going to solve some questions under math, and these questions have come from different topics, and this is the past paper for 2024. Okay, so the first question which I have is saying, part A, consider the universal set R being equal to from negative infinity to positive infinity, and also saying that each subset we have got x from negative infinity to 5 is included, y is negative 3 to 7 is included, then z is 10 to positive infinity. Find the following sets and display them on the number line. So it is okay for us first to display them on the number line, then it's going to give us the set now. So the first question which you have, we can clearly see that it's telling us that x complement minus y complement. We know that when there is minus, it's basically the same as intersection. Then we have to put a complement. Now this complement is for the minus. So if you have got two complement and complement will cancel. Meaning I've got x complement intersection y. So now I'm trying to find x complement intersection y. Okay? So first come up with a number line. So here is my number line. Okay? And you always put the inverse. So this number line is the inverse actually from negative infinity all the way to positive infinity. So I'll put 0 here. The negative number which I have is only 3. And again, the positive numbers, I've got 5, 7, and 10. So 5, 7, and 10. Now from here, we can clearly see that we have got x complement. What is x complement? So x complement is from negative infinity, or x is from negative infinity to 5. But the complement, you exclude that part. So you exclude negative infinity to 5. So I exclude this from negative infinity to 5. I exclude it. So meaning the complement, since 5 is included in the set of A, the complement 5 should not be included. So it's going to be open all the way to positive infinity. That is my x complement. So if I go to y, what is y? Y is from negative 3, not included, all the way to 7. 7 is included. 7 is here. So I join these two lines, and that is my y. So where these two intersect, that is the answer we are trying to find. So where I have shaded, that is the part where it is x complement minus y complement. So therefore x complement minus y complement is equal to from this point all the way to 7, but 5 is not included. Remember, 5 is not included, but 7 is included. That's my answer. Now you need to be very much careful here. We're not supposed to say x complement. We're not supposed to say x complement intersection y. No, because why am I not going to do this? I just manipulated this for me to make things easy. So you have to use the original when reporting, like the way I've done it here. X complement minus y complement is equal to 5, 7. Okay? 7 is included, 5 is not included. As simple as that. So that's the answer for part A. Now let's try to do part B. So I'm going to use the same number line. I'm not going to get rid of the number line. So we can also manipulate it a bit where we are saying z intersection x minus y complement. So bring the complement inside, or before you do that, first deal with what is in the brackets. So this is z x intersection y complement, because minus symbolize that then the symbol which is after minus, you need to put complement. So there's also a complement outside. Okay, and then it's going to be z intersection x. I bring complement inside, complement union. The moment you bring the complement inside, it's now going to be union complement. So complement and complement will cancel, and you end up having z intersection x complement union y. So now what we are trying to find is z intersection open bracket x complement union y. As simple as that. Okay, now we can go ahead and plug in the values. What I mean is, what is x complement? You remember we had x complement from 5 not included all the way to positive infinity. So it's going like that. That is x complement. What of y? Y, we said, is from negative 3 all the way to 7. Negative 3 not included, 7 is included. Okay, so that's my z. So that's being my z, or y, sorry. Z is from 10 to positive infinity. 10 is here. Is 10 included? No. All the way to positive infinity. That's my z. Now, first thing we have to understand is that x complement union y, it is this part here. Okay. Now, where I have shaded red, where it intersected with what? Z. So I can clearly see that it's this point. This was starting from 10, remember, so we can put 10 here straight up. That's 10. That's where they intersect. So where I've shaded green, that is the answer. So where I've shaded green, it is z intersection open brackets x minus y complement. So z intersection x minus y complement, starting from 10 not included all the way to positive infinity. Here, another thing, you can also use what we call absorption rule. But anyway, I'm not going to go there because it might maybe confuse you or something. If you're confused with this method, another method which I can teach you, the simplest one, maybe you can call it the simplest one if you want. You can expand this. You know that it's going to be z intersection x complement, then union z intersection y. You can also find this. So let's now get rid of this. We try to find what I have just expanded here. We see if we're going to end up with the same answer. So the first thing is z intersection x. So I'll put first z. Z is from negative, or is from 10 to positive infinity. So here positive infinity, that is z. X complement is from 5 all the way. So z complement, it is this point here. That is z complement. Again, we have z and y. So where is z and y? Z is again 10 to that one. Then we want y. Y is negative 3 to 7. Negative 3 not included, 7 is included. That's my y. Now I can clearly see that y and z, they are not intersecting. So if we add, we union them. That's what it means, okay? So the intersection of this is empty set. The intersection of z, so it's like the intersection of this one is the intersection of this one is 10 all the way to positive infinity, union. This one is empty set because they don't meet. There is no any point where z and y they meet. So 10 union, or 10 comma infinity union empty set, it is 10 comma infinity, like that. If you want, so you choose which one to go with. As simple as that, guys. So we're still on question 1. Now we have question 1b. 1, they're saying when divided by x plus 2, the expression 5x to the power 3 minus 3x squared plus ax plus 7 leaves a remainder of r. when the expression 4x to the power 3 plus ax squared plus 7x minus 4 is uh, is divided by x plus 2, there is a remainder of 2r. Find the value of a constant a. So we want to find the value of constant a. And remember, we are saying that, when you have got an expression y being equal to 3x squared plus 2x plus maybe x minus 1, if the remainder is 0, that's the reason why we equate this equal to 0. So now at this point, what we are going to do is we are going to equate this equal to what we have been told, that is the remainder. So they're saying that x plus 2 is equal to 0. So if I find the value of x, meaning x is equal to 2, is negative 2. So if I plug in negative 2 in this equation, the remainder is, I'll equate it equal to r. Same with this one. If I plug in negative 2 because it's also x plus 2, the remainder is 2r. So let's start with the first one. 5, I plug in negative 2 raised to a power 3 minus 3, then I put negative 2 raised to a power 2 plus a negative 2 plus 7. This should be equated equal to r. That's the remainder. Okay, so if I do negative 2, negative 3 raised to the power, that should be 8. So 8, negative 8 times 4, negative 8 times 5 is negative 40, minus negative 2 squared 4, so that is going to give me minus 12. Then that will be minus 2a plus 7 being equal to r. So I can now simplify this. Negative 40 minus 12 plus 7. Okay, so if you first start with it, that is going to give you 52. 52 minus negative 52 plus 7, it should be 45. So it's negative 45. Okay, so negative 45 minus 2a being equal to r. So I'll leave this one. Allow me to leave this one here. We call it equation 1. Let's now go to the second one. The second one, we've been told that if we plug in 3 or negative 2, then we have I'm just plugging in, the remainder is 2r. As usual, this is going to be 4 times 8 times 4 is negative, so it's going to be negative 32, plus it's going to be plus 4a, then this is going to be negative 14 minus 4 being equal to 2r. If I simplify this, these two will give me negative 16. So negative 32 minus 16, not really 16, it's going to be 18, right? Yeah, it's going to be 18, and I'll end up having 50, so it's going to be negative 50. Negative 50 plus 4a should be equal to 2r. But to make things simple, I can divide both sides by 2 to reduce it, so it will be negative 25 plus 2a being equal to r. That is equation 2. Now I can get rid of this. So now we can the r we are talking about is the same thing, so we equate r equal to each other. Okay, so we are going to equate this equal to that, because r and r, they are the same. The question is trying us to find, we are saying we should find the value of a. So I'm going to say negative 45 minus 2a is equal to, I'll equate it to negative 25 plus 2a, like that. Okay, have we done the right thing? Yes. So what I'm going to do now, I'll shift this to go to the other side and that to go to the other side. So negative 45 plus 25 being equal to 2a plus 2a. These two, if I do minus, I know that 50 minus 25, it is 25. So 45 minus 25 meaning should be negative 20. So 2a plus 2a is 4a. Divide both sides by 4, even here by 4. These will cancel. A will be equal to 4 into negative 20 is negative 5. And for sure, if you plug in 5 where there is a, the remainder should be the same. For the first one, the remainder should be r. For the second one, the remainder should be 2r. Okay. Now, in a case where sometimes they were trying to ask us also to find r, what you choose any equation here since you have got a. But in this case, the question is just asking us to find constant a, which is negative 5. Done. But in a case where the question was asking us to find a and r, so r, you choose any equation. For example, let me choose the second one being equal to r. So where there is a, then you plug in negative 5, should be equal to r. And then you are going to have negative 25 minus 10 being equal to r. So r will be negative 30. Okay, that's what we should know. So there is nothing complicated about B1. Let's try to solve also B2. So B2 is saying express the number negative 2.5132 as a fraction in form of a over b, where a and b are integers. The first thing we should have to do when you're expressing such numbers is to shift the power. It should go where there is near a bar. What I mean is you shift, this is a decimal, so you shift 1 2 because a bar starts from 3. So I've shifted how many? Twice. 1 2. So I have to say 100x being equal to negative 251.32. I put even a bar like that. The next thing, I have now to move from the original all the way to the last number. Okay, so I'll move from here 1 2 3 4. So I have to put just 4 zeros being equal to, I'll do the same. Then I put again point, then this one continues like that. So if I do minus here, okay, if I do minus, I will end up having negative 9,900. Okay, because 9,900 plus 100, it should be, yeah, it should be 10,000. So we are doing 100 minus 10,000. Should be, yes, 9,900. Now there is x. I'll put x here. This should be equal to, now this is more like we are saying negative. Then negative is going to be positive. So this is going to give me positive 24,881 if you do minus 0.00. So we can divide both sides by negative 900, even here negative 9900. So these will cancel out, meaning that x is now negative 24,881 divided by 900. You end there, because I don't think there's a number which can go into those two numbers. So, and then we can't go anywhere, we end there. So that is going to be my final answer. And if you divide that into that, we should be able to get back our answer to be that one. If you want, you can do the opposite. What I mean is, You can first put 10,000 x and put negative 20 this. Then you put now 100 x being equal to negative 25, so you put it here. You put it here is 251, so starting from here 0.32, which is negative. Then you do minus, you still end up having 900. Then you have now negative 2481, or it's 881. So here there is x, you divide both sides by that, x being equal to still the same. So you choose which method to go with, but you end up having the same thing actually. So that is it for part B 1 and 2. So let's now go ahead and also solve part C, which is under the quadratic nature of the roots. So the question is saying the equation ax squared plus bx plus 1 is equal to 0 has roots alpha and beta. If alpha plus beta is negative 2 and alpha times beta is 1, find part 1 the values of a and b, part 2 an equation whose roots are 1 over alpha and 1 over beta. So there we go. We start with the first one. They want us to find the value of a and b, and we do know, guys, that when we're talking about these things, alpha and beta, we know that alpha plus beta, okay, we know that alpha plus beta is equal to negative b over a, and alpha times beta is equal to c over a. So it's just a matter of plugging in the values. Let's start with the first one. Alpha plus beta is negative b. What is negative b? Okay, so we have negative b over a. Now alpha plus beta, we've been told that alpha plus beta is negative 2, so put negative 2 here, being equal to negative b over a. So this is a, we've been told a, that is b, and that is c. We know that already. So alpha times beta is c. Alpha times beta is 1. Then c is 1. We can see clearly, see there is 1. I divide this by a. So if I cross multiply, a will be equal to 1. So that's the value of a. A is 1. Now I'll come back here. This is negative b, so I put 1. I cross multiply, I'll have negative b being equal to negative 2. If I divide both sides by negative, b will be equal to 2. So the values of a is 1. B, the value of b is b is equal to 2, like that. So those are the values of a. Then a and b. Now another thing here is when we're talking about equation of the root is given by x squared minus alpha plus beta times x plus alpha times beta is equal to 0. So it's a matter of us now finding alpha times beta and alpha plus beta and alpha times beta. But how can we find this? Okay, yeah, how can we find this? Oh, let me do this first. To find this, we have been given like an equation whose roots are 1 over alpha and 1 over beta. So we have to add these. So first, for me to find alpha plus beta, we're adding. So it's 1 over alpha plus 1 over beta. So you find the common denominator. Is alpha times beta. So alpha times beta, now alpha and alpha will cancel out. I'll have beta. Beta into alpha times beta. Beta and beta will cancel. I'll have alpha. I can rearrange this because plus is commutative. So now it is alpha plus beta. Alpha plus beta I divide it by alpha times beta. And we definitely know that alpha plus beta, we have been given it already. Alpha plus beta is negative 2. Alpha times beta is 1, so it's negative 2. So my alpha plus beta is basically negative 2. Then I'll go now to alpha times beta, where I'm going to divide them. Okay, so alpha, okay, so I have what I've been given is 1 over alpha. I need to do times 1 over beta. So if I do times, I'll end up having 1 over alpha times beta. So alpha times beta is 1. So therefore, alpha times beta is equal to 1. So from the equation here, you just come and plug in the values. Okay, so x squared minus alpha times beta, or alpha plus beta, is negative 2 times x plus alpha plus beta is 1 is equal to 0. X squared plus negative and negative is positive, and I'll end up having this. So is equal to 0. So this is the equation they wanted us to find. You know, they're not that complicated, guys. It's just a matter of us understanding what we've been given. So when you've been given these things, just add this and that. Later on, come and do times. Then you come back and plug in the values in this equation. As simple as that. Okay. Now let us talk about question 2. So question 2a1, which is saying simplify 1 minus 2 root 11 over root 11 minus 1, giving your answer in the form of p plus q the root of 11, where p and q are rational numbers. Okay, so in short, we're just trying to rationalize the denominator, that's all. So we can clearly see that we do take the conjugate of the surd. In this case, the surd is negative, the square root of 11. So I'm going to rewrite this in this form. I'm going to say 1 minus 2 root 11. We divide it by, I'm starting with that, then I'll write it like that. So that when I take the conjugate, I should not be disturbed. If you want, you can just do it direct, where you're going to put negative. You're going to take this conjugate, then you're going to put negative now there when you're taking the conjugate. So this will be negative 1 minus root of 11, negative 1 minus root of 11, like that. So if I do times, I can clearly say that 1 times negative 1 is negative 1. 1 times negative root of 11, negative root of 11. 2 root of 11 times negative 1. Negative and negative will cancel. I'll end up having positive 2 root of 11. So those two, if I do my times, I'll end up having this, which is 22 perhaps. Yeah. So I divide this. You know, when you're multiplying anything by its conjugate, it's basically the same as just squaring the part having negative. If you're not getting it, you can just do it. Negative 1 times negative 1, negative 1 times root of that. It will still give you the same. So what I mean is, you square the part having negative. So this negative, don't square it, just leave it. But I'm going to square this because it's part of 1. This is part of root of 11, but it's because I had just to manipulate it. That's the reason why I'm not going to square it. Okay, so now I'll have negative 11. These two, I'll end up having positive, is 1 actually, negative 1 plus these two is root of 11, because 1 plus negative 1 plus 2 is 1. Then I'll have this 22. I divide this by negative 1 squared is 1, then that is going to be negative 11. Okay, so this is going to give me negative 11, so that is going to be negative 20. We have negative 11 and okay, so let's just check it here. So here when we had this times that, negative and negative is supposed to give us positive, right? So that is supposed to be positive. So positive, negative, and that one should be 21. Okay, plus root of 11. I divide this by negative 10. So now this, I want to put it in the form of that. So I'll just say negative 21 divided by 10. Then minus, I'll say 1 over 10. Then the root of 11. So why am I doing this? I'm doing this because I had to put 1 on top, because my P is now that, my Q is this, then now that root of 11. As simple as that, guys. Okay, so try to follow the simple steps I've done. But if you want, you can also do direct. What I mean is, you don't have to flip this, you don't have to change. Just put it the way it is. Then when you conjugate it, it's going to be negative root of 11 minus 1, which is going to give you simply the same answer. Let's try to solve part 2, which is under calculus, which is saying find y dx. So we have y being equal to ln natural log of cos squared x. One thing I want us to understand is that if I have got the natural log of u, if y is equal to natural log of u, then dy over dx is basically u prime divided by u. So initially here, for me to find dy over dx, I should just know that I should take the derivative of cos squared x over the original cos squared x. Now let's take the derivative of cos squared x. So cos squared x, it can be written as this. Cos x raised to the power 2. It's the same thing. So here I can use chain rule. You drop the power, keep this constant. Okay. You keep this constant. Then you do, the power reduces by 1, which is going to be just 1, times the derivative of what is inside. So now, what is the derivative of cos? It's negative sign. Okay. So what I'm going to do now, I'll put this sign to go with 2. So negative to go with 2. So it's going to be negative 2. I can start with sine x cos x. So I'll replace this with what I have there. So I'll say dy over dx is negative 2 sine x cos x. Okay, we're using x, not theta, right? Yes. So here I'm supposed to say x. Now I divide this by cos squared x. Sometimes, if you want to make things simple, let me just do this. You know, guys, that 2 sine x cos x can be replaced. So now there is negative, so we have got 2 sine x cos x can be replaced by, so it's going to can be replaced by sine 2 theta. But if you want, you can plug in this one. You put it in there, and it's going to end there. I don't want to do this because I want us to make this question to be unique. What do I mean? So I've replaced it with everything here. So now I can clearly say that cos, this cos and one cos can go. So I'll end up having dy dx being equal to negative sine x, okay, over, so there is 2 here, let's not forget, cos x. Sine over cos is tan. So therefore the derivative of this is now negative 2 tan x, like that. But if you want, you can also end like the way I did it. You just say negative sine 2 x divided by cos squared x. They will still give you a mark if you leave it there. So you can either end here or you do it like the way I've done it there. Okay, so to make things unique, go with this one. So that is it for part 2. Okay, question 2. So now let's go to question 2b1. Given that z is equal to negative 1 plus I, find the value of z conjugate. When you put z bar, it's basically the same as z conjugate. So z bar is negative 1 minus I, because I need to change the sign where there is I. Okay, so we have the square root of, I'll put negative 1 minus I, then again minus I minus 3, I squared. So I'll have now these two will give me negative 4, right? Negative 1 minus 3 is negative 4. So I'll have negative 4 minus 2I squared. So if you have got something which is in the modulus and it is squared, it's basically the same as you square root it, so you are finding the magnitude plus that. That's what we normally do. So if we can clearly see here that 4 squared is 16, negative 4 squared is 16 plus 4, which is going to be 25. 20, not 25. So this one can be written as 4 times 5. The square root of 4 times the square root of 5. So it can be 2 root of 5. So if you have been given something in the square root, in the modulus, and it is squared, then you have to put it in the square root. You are finding the magnitude in that case. Okay, so the answer here is this, 2 root 5. Let's go to part 2. Part 2 now, it's also interesting. One thing we should take note is that I squared is negative 1. Okay, so if I have got I to the power 18, for example, let's start with I to the power 3. It's the same as I to the power 3 times I. So this is going to be negative 1 times the I. So I'll end up having negative I, meaning that if I rewrite this, 5 divided by I plus 2, then I'll have negative I minus. Now let's go ahead and also do I to the power 18. So I to the power 18, you can bring I 9 times if you want. Or if you want, you can bring I, yeah, but 9 times is going to be easy. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And you know that I squared is negative, so then you replace it with negative. This is negative 1, that's 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 negative 1. How many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So you know that negative times negative is positive, so these 2 is positive 1, positive 1, positive 1, positive 1, and I'll end up having negative 1, because positive 1 times negative 1 is negative 1. So I have got now 20 divided by negative 1, of which is same as plus 20. So I have 5I plus 2 over negative I, then plus 20. Of which, again, to make things simple, again, let's not complicate things. It's the same as 5 over I minus 2 over I plus 20. Now you can get the conjugate. Now you say 5 divided by I times negative I over negative I minus, so you put these ones in there in the brackets, negative 2 over I, then times negative I over negative I, like that, plus 20. So if we do the math, I'll have negative 5I over negative I squared minus, so negative and negative now is going to be plus 2I over, because this negative and that negative will be positive, divided by I squared, like that, then plus 20. So I squared, so it's going to be negative 5i. I divide it by negative I squared is negative 1 plus 2i. I squared is negative 1, like that. So now this is going to be negative 5i, but remember there is 20 here. Then we have okay, what do we have? So we have plus 2. So now divided by 1. Even here we divide it by 1. 2i, this is 2i plus 20. We can get rid of this to create space. So we have now negative 5i plus 2i plus 20. So this will give me negative 3i plus 20. But the question is, we leave the answer in form of a plus ib. So the first one should be the real number. So it's 20 minus I minus 3i. So that's the answer. Okay, that is it for part B. Let us now go to go and solve question 3c, which is also still under calculus, and is saying the equation of the curve be given by y is equal to x plus 1 divided by x minus 1. Find the equation of the tangent to the curve at x is equal to 2. But 2, we need to find the equation of the normal. Now, when we're finding the equation, is given the equation of the tangent or the equation of the normal is given by this: y minus y1 being equal to m, which is the gradient, x minus x1. Now, y x1 is the x which we are going to be given. Okay, for you to find y1, you have to plug in the value of x in the original equation. Okay, so what I mean is this: y will be equal to, if I plug in x to be 2, so it will be 2 plus 1 divided by 2 minus 1. So y will be equal to 3. Is 3 divided by 1. So y is 3. So now our x1 is 2 for both actually. Then our y1 is 3. Now after finding the y and x, you have now to find the gradient. To find the gradient, you have first to differentiate the equation. When you differentiate, then you plug in where there is x, you put what you have been given. X is equal to 2, so we're going to put x is equal to 2 and find the gradient, which is m. So how do you differentiate a fraction? So in this case, we're going to use what we call a quotient rule. So quotient rule, dy over dx is given by u prime, okay, u prime v minus u v prime divided by v squared, like that. So here we're going to say let u be equal to x plus 1, which is on top. Then u prime, it will be 1. V is x minus 1. V prime is also 1. The derivative of x is 1 because you drop the power reduces by 1. So it is 1 raised to the power. Okay, yes, it's 1 actually. So 1 raised to the power 1x raised to the power 0. Any number to the power 0 is 1. The derivative of any constant like 1 is 0. That's why it's just 1. Even here it's just 1. Let's plug in the values we see. So dy over dx will be equal to u prime is 1, v is x minus 1 minus u is x plus 1, v prime is 1. I divide this by v squared, so x minus 1 squared. To simplify this, dy over dx will be equal to is x minus 1 minus x minus 1. Okay, so we can clearly see that x and x down there, they will cancel out. So I'll have dy over dx being equal to x and x will go, x minus x is 0. So negative 1 minus 1 is negative 2. X minus 1. Don't simplify, don't expand the denominator, because you have to plug in the values. Okay, you will have to plug in the values. So now you say x should be equal to 2. We have been told that x is equal to 2. So where there is x, you put now 2 minus 1, then you square it. So you end up having negative 2. 2 minus 1 is 1. 1 squared is 1. So the gradient is negative 2. So you say therefore m is equal to negative 2. Then now you can go ahead and find the equation of the tangent. So you just plug in the values. Y from this equation I gave you, y minus y1 is, we found 3, the gradient is negative 2, x you put the way it is, then x1 is 2. So you do y minus 3 negative 2x plus 4, shift this to the other side, y will be equal to negative 2x plus 4 plus 3. So y will be equal to negative 2x plus 7. So negative 2x plus 7 is my equation of the tangent. Okay, now how do you find the equation of the normal? So I'll put this one here. Equation of the tangent, the first part. So I've solved the first part. How do you find the equation of the normal? The equation of the normal, the only thing which is going to change is the gradient. So you have to find gradient 2. So you have got, this is what the first gradient you find, that is the gradient for the equation of the tangent. So you say m1 is, this is m1 initially, times m2 being equal to negative 1. So you plug in the values, negative 2 times m2 being equal to negative 1. So divide both sides by negative 2 and m2 will be equal to negative 2 over negative 2. m2 will be now 1 over 2. So the gradient which we're going to use, which is the gradient of the normal, is now 1 over 2. Then the rest is the same. So you use the same formula. I'm going to use the same formula, which is that one, which is y minus y1 being equal to m x minus x1. So y1 is 3, the gradient is half, x minus the x1 is 2. So y, this is minus 3 being equal to half, x minus half times 1 is, that's going to give me that. So y will be equal to half x minus 1 plus 3. Y will be equal to half x plus 2. So this is my equation of the normal. Now the trick part here, guys, sometimes if you know that other method which we say y is equal to mx plus c, it's okay. Then you go ahead and find this, the value of c. It's fine. But still, you need to find y. For example, let me show you how to find the equation of the normal. We have found this using that formula. Now let's do the reverse. Y, we have found 3. The gradient is 2. We found 2 or negative 2. Negative 2. Then we have x is 2 plus c. Okay, so we have 3 being equal to negative 4 plus c. Shift 4 to the other side, it will have this. So 7 is my c. So from this equation now you just plug in the values direct. If you are okay with this other method, so you say y is equal to, my m is negative 2, so put x, then c is 7. So you see, you end up having the same answer. Same for that other one. You can also use the same one if you want. There's no problem with that one. So you can find also c. So you say use the same, y is equal to, so there are two formulas. It's either you use this one or you use that one. So y is still 3, but I still feel like this is simple, because the y you find is y1, The x you have been given is x1. Then you just plug in the values. You leave x and y. Then you plug in the values where there's x1 and x1 and y1. So the gradient is negative, or y is 3. That is negative 2 x2 plus c. Or the gradient now for the normal is half actually. Then that is 2 plus c. So it will be 3. These 2 will be 1. Okay, plus c. 3 shift that one to the other side, it will be 2. So meaning you have this, plug in the values, the gradient is half, then 1 is c is 2. It's basically the same as that. So you choose which one to go with, as simple as that. Okay, so let's go ahead and also talk about question 3, which is asking us about this is completing square method anyway. So the question is saying let f of x being equal to negative x squared plus 2x plus 1. Part 1 is saying by completing the square, express f of x in the form of f of x is equal to a open brackets x minus h squared plus k, where a, h and k are constant to be determined. Part 2, sketch the graph of f of x indicating the turning point, x-intercept and y-intercept. Okay, so let's first start with the first one. So the first one, guys, is when we're dealing with completing square method, you first have, this is a function which is in the form of ax squared plus bx plus c. So you always factor out a. In this case, a is negative 1. I'll factor out negative 1. Then here is positive. So if I divide that, it's going to give me, if I divide negative 1 into positive 2x is negative 2x. I divide negative 1 into positive 1 is negative 1. Why am I doing this? If I multiply this by that, by everything inside, I should go back to that. Okay? So now from here, what I'm going to do is, we know that completing square method, when the moment you factor out a, the next step is you write this, then you do plus, okay, open brackets, half of the number which is having x. So what is the half of the number which is having x? The number which is having x only, not x squared, but x only. So or if you don't understand when I say half, you do times the number which is having x, do times half. It's the same as half. So it's going to give me negative 1. So I'll put negative 1. The moment you find this, you have to square it. Then the same thing, just do minus, you get the same thing. Square it, then minus 1, like that. Okay, so the only trick part here is this part. You get the number which is just having x. If it is negative, just get as negative. Do times half, times 1 over 2. Find the answer. That is the answer you're going to put there. Already you have put plus here. Then you have to square. Minus. The same things which you have put in the brackets here, they are the ones you're going to put there. Then square it as well. Okay. Then now, the next step, you rewrite this. The next step, guys, is you have to get this and that. So this you are going to ignore it. So you are going to write now, you open, then x minus 1. They are both squared, so you just put square. Then minus is this one. Negative 1 squared is 1. But again, we have got 1. You keep on bringing 1. X minus 1, you square it. Negative 1 minus 1 is negative 2. Like that. When you reach at this point now, we want to make this in a form of, we have been guided, okay? We've been guided already. So now what I'm going to do, the next step is I need just to open the big bracket. So I'll multiply negative 1 with everything. So I have negative 1, then x minus 1 squared, then negative 1 times negative 2 is positive 2. So I can clearly see that this thing which I've been asked to find, a x plus h or x minus h squared plus k, is basically equal to negative 1 x minus 1 squared plus 2. So a is negative 1, h is 1, then k is 2. As simple as that. So I've expressed this in form of that. Now the next question is asking us with sketch. Now sketching, we need first to come up with the turning point. The turning point, how do you find the turning point? The turning point is where the graph is going to turn. So you get x and y. So x, you get the opposite sign of what you have here, the number which doesn't have x. That is negative 1. The opposite of it is 1, comma. This constant, just get the way it is. If it is positive, get positive. If it is negative, get the way it is negative. So I'll put it in there, positive 2. That is my turning point. After finding that, the question continues to say we need to indicate the turning point, which is that what we have found there, the intercept, which is y and x intercept. Let's first find the x intercept. So how do you find the x intercept? To find the x intercept, set y equal to 0. So it is now 0. The equation is y is equal to negative x squared plus 2x plus 1. So you equate y to be equal to 0. What is happening, guys, is this. In most cases, sometimes if you want, you can use product sum, but in most cases you use the quadratic equation formula because it doesn't work when you use the product sum. It's not factorizable. So the product is negative 1, the sum is positive 2. So the product is less than the sum, so it's not possible. Okay, and this is negative unless this was negative, but still it doesn't make sense. So I'm going to use that other method, which is x is equal to negative b plus or minus b squared minus 4 ac. I divide this by 2a. We plug in the values. X will be equal to negative b plus or minus, but let's first plug in the values. Why am I writing negative b again? X will be equal to, so now this is a, this is b, and that's c. So b is basically negative 2, or is 2, but it's going to be negative plus or minus, then again 2, I square it, minus 4, a is negative 1, c is 1. Divide this by 2, that. Negative 2 plus or minus, this will be 4 plus, okay, it will be 4 plus what? Because why is it going? It's going to be 4 plus 4. Negative 2. Then x is equal to negative 2 plus or minus, this is 8. I have negative 2. So to simplify it, it's the same as I say x is equal to negative 2 plus or minus the square root of 4. It can be the square root of 4 divided times the square root of 2. I divide it by that. So x will be equal to negative 2 plus or minus the square root of 4 is 2, root of 2 divided by that. Okay, we get rid of this because I want this to be just here. So x, we have got negative 2 plus 2 root 2. Or before I even go there, to make things simple, just here x will be equal to, I can divide everywhere, okay, with 2. So it's going to be -1, okay, then plus or minus, here is also 1, so it's just the root of 2, then divided by -1. So that I come here and say x will be equal to -1, okay, plus root 2, then again here -1, or x will be equal to -1 minus root of 2 divided by -1. So now I can find the values of x. So x will be equal to negative is going to be positive everywhere here. It's going to be 1 minus that. Okay. Then the other one will be x to be equal to, everything will be positive. Like that. So these are the x-intercept. Then to find the y-intercept, equate x equal to 0. So you just plug in where there is x, put 0. So you have, I can put, I think, the x-intercept here. X is equal to 1 minus root of 2, and also x is 1 plus root of 2. Okay. So to find the y-intercept, how do we find the y-intercept? So y-intercept, you have to equate x equal to 0. So what is happening, guys, is y is equal to -x squared, yes, plus 2x plus 1. Plug in where there is x with 0. So y will be equal to, this is plus 1. So everything here is going to be 0, is going to be 1. So y is 1. Okay. Now, after finding this, what next are we supposed to do? The next thing we have to do now, we can sketch this. Okay. We can sketch this. So how do we sketch? Now we should understand that the one which is going to be to the positive side, it is 1 plus 2, because 1 minus root of 2 is greater than 1, so it's going to be negative, but it's going to be just near here, so you put 1 minus root of 2. Okay, 1 plus root of 2 is greater than 1, so this 1 for the turning point, or let me say this, I'm going to put 1 plus root of 2 here. The turning point, we have got 1 and 2. The y-intercept, where it has to cut in y-axis, let me put 2 on top here. In y-axis is at 1. What does it mean? It means that the graph is going to touch this, is going to cross this point and that point, that is x-intercept, and also y-intercept that. Then it has to come, this is the turning point where the graph is going to turn, 1, 2. When we reach at 1, 2, it is here. Okay, that's 1, 2. So when it reaches here, it has to turn. So the graph will look like this. It comes there, it reaches there, then it turns like that. Now let me draw a neat line. It reaches there, it goes like that. Yeah. So this other one, I can get rid of it. Okay. Yeah. So that is the graph of, so you even indicate here, this is 1, 2. So if you want, yeah, that is how we do it. So f of x, you even put it like that, is equal to -x squared plus 2x plus 1. As simple as that. So it is not complicated to do completing square method. So here I've exhausted almost everything. But now in a case where the same question, Now I'm going to explain everything here. So this is the answer actually for sketching. But in a case where, guys, they ask us to sketch the same thing, where now they just add a modulus here. So they add a modulus, they want us to sketch the part having negative, just reflect it to the positive part, like that. Then delete this. That is when there is modulus. What if there is a modulus, but again there is negative outside? There is a modulus, but again outside there is negative. What it means that reflect the positive part here to come this side. So meaning that here there will be -1, here there will be -2. So it will come there, it will punch there, you just reflect it down part, it comes there. Then you get rid of, if you want you can leave this one in dotted form, the original one. If there is modulus, then there is also negative outside. That's what we do. But for this one there is no modulus and there is nothing, so the answer is just that is the graph which we have found there. That's all. So that is it for this question. Let us now talk about question 3b, which is saying find two positive numbers whose sum is 100 and the sum of whose square is the minimum. Okay, so we are saying that we need to find two numbers. So those two numbers, we don't know them, but they're saying if you add those two numbers, you need to get the sum of what? The sum, which is going to be 100. So we can say that x plus y, which we don't know, should give us 100. But again they are saying that and the sum of whose squares is minimum. So when we're talking about minimum, or maybe they use minimum or maximum, meaning we are interested in the what? The function. It's more like a function now. Okay, so it's like now the minimum, now you have f of x being equal to x squared plus y squared. That's what they're trying to tell us. So now for this one, we can just try to make y as a subject of formula. So y will be equal to 100 minus x. In the second equation, this function, where there is y, let's put 100 minus x, but it is squared. So we expand now. Okay, we now expand. So how are we going to expand it? So we have got f of x being equal to, we have got x squared plus 100 times 100 should be 10,000. So I'll put it in the brackets. Okay, yeah, it should be 10,000. Then 100 times x, it should be 100 x. X times that is c, 100 still x, then plus x squared, like that. I can now open the brackets. So x, okay, so I've got x squared plus 10,000. These two can give me 200x plus x squared. X squared and x squared can add up, which is going to give me 2x squared, then minus 200x plus 10,000. So this is the function. Now to find the minimum, when we are trying to find the minimum, it's more like we are trying to find the value of x. Okay, so we use this formula in case you have never heard of it. So it is x is given by negative b divided by 2a. That's what we use. So here I know that this is a, this is b, and this is c. So I have got x is equal to negative, my b is negative 200. Then my a is 2. Okay, so then I can clearly see that I'm going to have x will be equal to positive 200 divided by 4. Therefore x is 50. So the value of x is 50. Okay, So if you know the value of x, then it's going to be easy to find that other value, which is the value of y, of which if I get rid of this, you will say y is equal to 100 minus x. So y is 100 minus 50. Y is also 50. We can clearly see here that the question was find two positive numbers whose sum is 100. 50 plus 50 is 100, and the sum of whose square is minimum. So if we square here like 50 squared and 50 squared again, the sum, if we add, that's the minimum we're talking about here. Okay, so that is it for part A. Let us go ahead and solve part B. The best way, maybe if you want, you can define this function and come back and sketch it, but it's going to take time. I'll use a shortcut because the question was just direct, sketch and state the range. When you've been given such kind of question and they're not demanding you to redefine it, just sketch it direct. How do you sketch it direct? Get what is in the modulus. X minus 1 equal to 0. So for x is equal to 1. So what you do now is this. Okay, what you do, you get two numbers or even three numbers up to. So now you put one in between. Put one in between. So you get two numbers, three numbers up, three numbers down. So if I get three numbers up, it's going to be 2, 3, and 4, like that. Again, I'm going to get three numbers up, which is going to be 0, -1, and -2. If I want, I can go as far as -1 if I want. Okay, -3, sorry. So I can go as far as -3, like that. So now I can start now plugging in the value. So we have, if I plug in -3, so it's going to be -3 minus 1 minus 3. It's going to be -4 minus 3. So it is 4 minus 3. The modulus of -4 is 4. So I'll end up having 1, meaning that is 1. If I put -2, it's going to be -2 minus that is -3. -3, the modulus of -3 is 3. 3 minus 3 is 0. You put 0 there. If I put -1, it's going to be 2. 2 minus 3, okay, it's going to be, if I put -1, -1 minus 1 is going to be -2, but it's 2, so minus 3, -1. So -1 has got also -1, like that. Now if I put 0, it will be -2. Okay, if I put 1, it will be 0. 0 minus 3, -3. If I put 2, it will be 2 minus 1, 1. 1 minus 3, -2. If I put 3, 3 minus 1 is 2, and I'll end up having -1. If I put 4, 4 minus 1 is 3. Then 3 minus 3 is 0. From here, just come up with a sketching, the graph. That's all. Stop even struggling yourself. Okay. So this graph, I can clearly see that in x I've got -1 to -3. I'll put here -1, -2, -3. Then in y, this is x, we already know that this is y. In y we have got, or again in positive we have got 1, 2, 3, 4. So I'll put 1, 2, 3, 4. 1, 2, 3, 4. If you want, you can also go as far as -4. It's fine. So if you put -4, -4, that one is going to be 5. 5 minus that one is 2. So it's like in y now you also have 2, that is -4. Okay. So in y we have got, in positive we have got 1 2, so I'll put here 1, I'll put 1 and 2. The negative we have got negative 1 2 3, so I'll put negative 1, negative 2 and negative 3. Now we can and 0. We can now do it. So negative 4 comma 2, negative 4 is here, 2 is there, so it's here, that point. What else? We also have negative 3 comma 1, negative 3 is there, comma 1 is here, just there. What else? We have negative 2 comma 0, which is here. What else? We have 0 comma, we have 0 in x, in y negative, just a minute, in x we have 0, which is this point. In y we have just a minute, this one is negative 1 comma 0, so it is in y. Now let's just start again. Negative 4 comma 2 is here, I'll put it at that point. Negative 3 comma 1 is here. Then we have got negative in x negative 1, okay, in x negative 2, let's not forget this. Then we have got 0, which is this point, yes. So negative 2 comma 0 is there. Negative 1 comma negative 1 is there. Then we have got 0 comma negative 2 is here. 1 comma negative 3 is there. What else? Or if I want, I can just, it's there. What else? Then we have got 2 comma negative 2. Okay, in x2, then negative 2 is here. 3 comma negative 1, in x3, then here negative 1 is there. 4 comma 0, so it's going there. So this graph comes like this. Okay, it comes like that, then it goes like that. So you have to put the arrows, because we do not know where the graph ends. So you put the arrow, you put the arrow, then you say this is f of x being equal to the modulus of x minus 1 minus 3. So that's how you sketch this without even defining it, without wasting time. Yeah, that's how you sketch. Actually, it's very easy. I can also sketch just using, maybe I can sketch using just from here, even just ending there. I can still sketch. I can still sketch because I'll know where the graph is going and I'll just open it. That's all. As simple as that. So that is it for part B. Now let us go ahead and also solve question 3. Question 3C actually. So this is under, we have inequality and also another discriminant, which is part 2. So if the first question is saying solve the inequality expressing your answer in interval notation. Okay, so we express the answer in interval notation. So there we go. Now, guys, I want you to be just, these things are just basics. The way this one is, it's the same as 2x minus 1 greater than or equal to x. I've just flipped. This one goes there, this one goes there. So the open side is to the 2 over x minus 1. So it's the same thing. When you do this, then you have to shift now. Just shift that x. Here remain with 0. Here you have 1. The common denominator is just x plus x minus 1. So x minus 1 into x minus 1 is 1. 1 times 2 is 2. Then here 1 into x minus 1 is x minus 1. Then we are going to have x open brackets x minus 1 again greater than or equal to 0. So it will be 2 minus x squared plus x, because negative and negative is going to cancel out, it's going to be positive. So we have this. So now the sign which we are dealing with now is the greater than. Okay, we are now dealing with the greater than, because I've flipped this one to be like that. So when you reach at this point, you get the numerator, which is 2. I can write that one to be, say, x squared plus x plus 2 greater than or equal to 0. Again, I get the denominator x minus 1 greater than or equal to 2. So x will be greater than or equal to 1 for the first one. So we solve for this one. Now is going to be the product. We have negative 1 times 2 is negative 2. The sum is positive 1. The factors, I think it should be positive 2 and negative 1. So that positive 2 times negative 1, it should give me negative 2. Positive 2 minus 1, it should give me positive 1. So I have negative 1, okay, minus x plus 2x plus 2 greater than or equal to 0. Factor out, this is squared, sorry. Factor out negative x, so it remain with x plus 1. Then here I'll factor out 2. I'll remain with x plus 1 as well, greater than or equal to 0. So then I have x plus 2 and x plus 1, like that. Now the next thing, let's do this, guys. I don't have enough space, so I know that it's greater than or equal to 0. So we have negative x plus 2 greater than or equal to 0, or x plus 1 greater than or equal to 0. Shift 2 to the other side, so we have this. If I divide both sides, the moment you divide it by negative, x will change, the sign will change to just 2, like that. But though it's not going to affect anything. That one is negative 1. Now we have 3 solutions here. And remember, this is an inequality. Just not forget that. Then you have to write here to say critical values. Our critical values, we have found 3. X is negative 1, and x is 1, and x is 2. Okay? When you do this, you come up with the table. The table you are going to come up with is going to look like this. So what is happening is, it's negative 1, we have 1 and also 2. So the numbers in between negative 1 is just 1.5. Here 3, here 0, here I can choose negative 2. Now we have 3 things. So this is what I'm going to do. The first one, remember, it is this one, x minus 1. The second one, we just get this, negative x plus 2. The third one is x plus 1. Then the last one, you have to put all of them. X minus 1, negative x plus 2, and x plus 2. Like that. So what is the next thing now? If I put negative 2 here, negative 2 minus 2 is negative. If I put here negative, negative is going to give me positive. Here, negative. Overall will be positive. If I put 0 here, it's going to give me negative. 0 there, positive. 0 here, positive. Overall, negative. Because negative times positive is negative. If I put 1.5 here, it's going to give me positive. I put there, it's going to give me still positive. Here is going to be positive, and I'll end up having positive. 3 here, positive. 3 there is going to be negative. 3 plus that, negative. Then 3 plus 1, 4, positive. Overall negative. So now that this sign we flipped it, we are now using this one, so it is greater than. So I'm going to get the part giving me positive, this part and that part. That will be my solutions. And the question is, we put them in set interval notation. So my solution set will be equal to, starting from this point included, since it is greater than or equal to, all the way to negative infinity. So it will start with negative infinity to -1, but this is included, union everything. Now we have got 1, 2 is this point all the way to that point included. So that's my answer. Now if you are confused, guys, if you want maybe to shift this to go to the other side, you still end up having the same answer. Nothing is going to change. Okay, don't think it's going to change. Everything will be the same. Okay, yeah, so nothing is going to change. So if you can try it, shift 2 over that to go to the other side, it will still be the same, because you are going to have x less than or equal to, you are going to have x minus 2 over x minus 1 less than or equal to 0. You still have the same answer. So now this one you are dealing with less than, so you will come and get the part which is giving you negative, but still the answer will not change. So you can try it out, you see the answer will not change. Okay, so try it out and see if you are going to get the same answer, but definitely you have to get the same answer. Now let us go ahead and do part 2. Okay, so part 2 is saying find the set of values of k for which the equation kx squared plus 8x plus 2 open brackets k plus 7 is equal to 0. Okay, so this one, what is happening, guys, is simple and straightforward. So we have, when we're dealing with this one, they're saying that has no real roots, and we express it in set interval notation. So this is, now we have the discriminant b squared minus 4ac. If it is equal to 0, let me start with greater than. If it is greater than 0, meaning it has got two distinct roots or real roots, two distinct real roots. If it is greater than 0, if b squared minus 4ac is equal to 0, it has got only one root. If b squared minus 4ac is less than 0, then it has got no real roots. So you have to know these two distinct real roots, meaning that the discriminant is greater than 0. One root, or one root, not roots, but one root, then the discriminant is equal to 0. No real roots, the discriminant is less than 0. As simple as that. So in this case, my discriminant is less than 0 because it is we don't have real roots. For a, c, so it's less than 0, like that. So now I know that this is a, this is b, and everything here is c. So b is 8, so 8 squared minus 4, my a is k. Then my c is 2 open brackets, or I can just do this, times 2 open brackets k plus 7. That is my x less than 0. So 8 squared is 64 minus, so it's more like I have 4 times 8, or if I want, yes, 4 times 2 is 8 k. I have k plus 7 less than 0, like that. Let's try to simplify it, and we end up having 64 minus, that is going to be 8k squared minus 8 times 7, that should be 50 something, 56. Okay, so it's going to be minus 56k, being less than 0. Now this one, to make things simple again, I can divide everything with what? 8 to reduce it, because these numbers are too big and they're complex, and it's going to take time for me to start working with them. So divide everywhere by 8, because I can clearly see that 8 can go into anything here. 8 there, it is 1, or it is, sorry, it is 8. So I'll have 8 minus k squared. 8 into 56 is 7, less than 8 into 0 is 0. I can rearrange this, which is the same as negative k squared minus 7k plus 8 less than 0, like that. Now I can now work around with the product and sum. So the product is negative 8. So the product we get the coefficient there times the number which doesn't have k. So it's going to be negative 8, because negative 1 times positive 8. Then the sum is negative 7. The number that have only k, or in a case where we are dealing with x, the number which has got x, not x squared but x. So what are the factors? So the factors should be negative 8 and positive 1. So that I do this time that I get this plus that, I'll be able to get this. Therefore, I'm going to have negative k squared plus k, okay, minus 8k plus 8 less than 0. Factor out negative k, open brackets, k minus 1. Factor out negative 8, k minus 1 less than 0. So then negative k minus 8 and also k minus 1 less than 0. So negative k minus 8 should be less than 0, comma, k minus 1 should be less than 0. So to find k, negative k will be less than 8. If I divide both sides by negative, the sign will change to negative 8 now. This one will be k is less than neg 1. Now, one thing we should understand is that we have more than 2 answers. If you have got more than 2 answers, always you go back to the table. That is an inequality. There is no debate about that. The moment you are dealing with anything which is greater than or less than, and then you find that you have got more than one solution, go back to the table and get the solution which is going to fit. In this case, I can clearly see that I have got my critical values, which are 2. So x, or is k actually, k is negative 8 and negative 1. Come up with a table. Okay. So what is happening now is this. So here I have got negative 8. And so was this positive? Just a minute. This is negative, guys. Just a minute. This is negative. We have shifted this to go to the other side, so it is positive and not negative. Take note of that. So we have got it. This should be positive now. So we have 1. So now the things which I'm going to be putting there inside, we have this guy and that guy. So I've got negative k minus 8. I also have k minus 1. So here you put everything like that. So let's now try to put in the values. So now here just get 0, here get 2, here get negative 9. So if I plug in negative 9 here, it's going to be positive 9. Positive 9 minus 8 is positive 1. So I have positive. If I plug in negative 9 minus 1 is negative 10. Negative. Positive negative is negative. If I plug in 0 here is negative. There, negative. Overall, positive. If I plug in 2 here, it's going to be negative 2. Okay. It's going to be negative 2 minus that is negative. Then 2 minus 1 is plus 1, which is positive. Overall, negative. Remember, the first thing we are using is less than, because it has got no real roots. You get the part having negative. So our solution will lie between this and that, and not this. So our solution set for k, so you say k is equal to, starting from here not included, all the way to negative infinity, and starting from here not included to positive infinity. So the k value should be from negative infinity to negative 8 not included, negative 8 and not 1, union from 1 all the way to positive infinity. So that's the answer for k. So that should not bring confusion. Just follow the simple steps. You are dealing with inequality, you have more than one answer. Use the table. Okay, so you refer to the initial, the sign which you have been using. That's all. That is it for part A. Question 3C.